No, you had to order it. So then we distribute it just to the people that's ordered.
Yep. Well, like, I just distributed our handouts to all of you guys.
So today we're going to talk about distribution and types of distributions and how they look on graphs. And really when we talk about this whole chapter, we're going to be talking about histograms. Okay, so it's how the data is spread out. Do you want to look at them before we throw them away? All right, so for a curve is where we have an up and over kind of motion. It's kind of like a mound or a hill. So it's a general shape that the data creates when put into a histogram. The general shape that the data creates when put into a histogram describes that curve. So remember, a histogram is like our bar graph, kind of talking about those frequencies. All right, next word we have is skew. Skew, if you walk in a room, if you're like a detective and you're like, something's askew. You might hear that word a lot, like, I don't know, like comics or cartoons. If something's askew, what does that mean? Yeah, it's not quite right. It doesn't mean everything is messed up. You don't walk in and go, oh, this is a mess. You just walk in and you're like, something's askew. Something's not quite right. Okay, so skew. Dear Mon, what do you need, dear? What do you need, dear? Oh. Okay, we shouldn't need to interrupt class for this. Okay. And then next time we can maybe get a drink of water after we're done so that we don't disrupt class. That's what I'm saying. Okay. All right. So skew means it's not quite right, so it's not centered. So it's not right in the middle. It doesn't look exactly the way that we like it to look. It's a little off. Or going towards one side. All right, we have 3 different types of skews that we're going to talk about today. We're going to be doing a lot of labeling and drawing here in these boxes. So I know it doesn't look like quite a lot of notes, not too much, but we do need to make sure we're really careful about how we draw these things so that we're ready for them. So we're going to draw in X and Y. Now this is where I'm going to use my first colored pencil is by drawing my curve. So for this first curve, it's like the hill happens right away. It's going to be like a hill right here, goes up, right away, right at the beginning, and then it goes down and kind of evens out at the end. So our hill is not centered in the graph. It happens right away, that curve. Now this is called a right skew. Or another name for it is a positive skew. Okay. Okay, so when we talk about it not being centered, we're saying it's not centered, it's a right skew, which can get a little confusing because when you look at this hump, okay, that hill, is that on the left or the right side? Yeah, it's kind of on the left side. So I get really confused about this because in my brain, this actually takes me a while. Like, I'll get better at it by, like, next Monday. I'll be like, oh, yeah, I got this down. But each year, it takes me a moment to realize how to do this again. Because I always think this is left, because it's on the left side. But this is a right skew. And the reason why is because the mean is to the right of the mode and the median. So we're to the right of. Is our key part there, the right part. So we're going to draw that in. So if I have the mean is our calculated center. So that means we're taking into account all of this data, and our calculated center is generally always near the middle. So our mean would be near that middle part. Okay, our mode means most, so where would we have most in this one? At the top of the hill, right? I have to do that yellow, I guess. So the mode is most. That's where our highest point in the hill is. So wherever your hill is, wherever that highest point is, that's that mode. So we're not talking about where the location of the hill is. We're talking about where's the location of the mean, the calculated average. Calculated average is to the right of the hill in location to that. And then we have our median, and our median is the actual middle when we go high, low, high, low, high, low. Most of our data here is right away, so our median is probably going to be a little bit closer to that mode somewhere over here. Okay, and that's not exact, that's just us estimating where those things would go. Okay, so a right skew means our calculated middle is still in the middle of what we would look at all of our data, but it's to the right of where most of the data ends up. A lot of our data ends up at the beginning. The mean is actually to the right there. So when we look at this in a histogram, it's not exact. As you look at this one to the right, is this exactly going down, down, down? Is it nice and smooth? No. So what we're actually looking at here, do we need a new one? Okay. You're having issues with the glue, or?
Yeah.
What? Okay. All right. So as we work through this, what it really is looking at is it's like we're taking kind of the tops of each of these and making a shape out of it. So overall, it goes up over that top one, and then it starts coming down. Now, it really goes down at that 7,000 to 8,000, but we'll just kind of show that it goes down there, and then eventually it works its way off to the side. Okay. This part that goes off to the side, that goes lower and lower, this is called the tail. Kind of like an animal's tail. Just kind of goes off to the side, drags out. All right, our next one we're going to draw it first. Again, we're going to have a x-axis and y-axis. Draw it on a graph. So these curves are relatively supposed to match kind of what they would look like on a histogram. So our main idea here is if I was going to draw a histogram underneath, it would relatively fit underneath there. But when you look at this, this is just the basic idea first. All right, this time we're going to have a hill, but the hill is going to be in the middle. So it's going to start low, and then it goes up, goes back down, and gets low again. And that hill is in the middle of our data, as best as you can there. All right, this one has a lot of terms for it. One that we normally call it, so if you want to write this one nice and big, because this is what we generally call it, is a normal curve, which is what this whole chapter is about. You guys, it happened. I said the chapter name. You guys know that in movies, like when they say the movie name, movie title? Okay. Okay, Dane, put your phone away. Actually listen. No, you're copying. You're not, like, listening. Not like learning, you're like doing other things at the same time. It's different. All right, so normal curve, lots of other words for this. We could call it no skew, so it's not going one way or the other. It's right in the middle, centered, so no skew. We could call it symmetrical. Does anyone remember what that word symmetrical means? Yeah, same on both sides, it like matches on both sides, so symmetrical. We also call it a bell curve. Or we could call this a perfect distribution. I'm going to do DIST for distribution, since that's what this whole chapter is about, or whole lesson's about. So, yeah. This is a, because it was a period.
But then on the other one, didn't you put a dot on both sides of the
Sure. Those are all names. Does that make you happier?
Yeah.
Okay. All right, so as we take a look at the normal curve, if you ever hear a teacher, we don't do this very much anymore because now we're all about standards-based grading. However, prior to standards-based grading, this is why standards are so important, is because as a school, we would say we want the most people getting C's. And then we want B's and D's to be the next biggest amounts. And then we should have a little people at the top with A's and a little people at the bottom with F's. And so some teachers, they would look at their class and say, oh no, I have too many F's. That means my highest F's should be getting A's. But did anyone actually learn what was going on in that class? No, because they all technically failed it. Or vice versa, if the teacher looks at their grade book and they're like, I have too many A's, I need to lower my standards, then if you really have an A, they'd be like, well, you're not the top A, so you actually get a B, or you actually get a C because you're the middle of everything. And that's how things used to be. So when I was in when I was in high school, and sometimes in college professors will still do this. They'll say, I'm grading on a curve. And what that means is that rather than taking it out of 100% of the test, they're going to take whoever has the highest score, that's what it's out of. So if it was out of 30 points, but the person that scored the highest got a 28, it's now out of 28 instead of 30. And that way it creates that curve. But now we do standards because now it's based on what you know. It's not based on what other people around you know. Does that make sense?
No.
What part didn't make sense? So the curve to get that, so that not everyone got A's. That's the goal. The goal is to get the most C's. So you would grade based on who the smartest kid is in your class. That's 100%, is to be the smartest kid. Now it's not based on any of the other kids, it's just based on what you know. So we don't do that anymore. Isn't that crazy? That's how we used to grade?
That's still how they grade when I was doing college. So for example, if you get a D, but everyone else doing kind of similar, they kind of curve it so you might get a C plus instead, just because they're trying to put everything in the middle.
Mm-hmm. So if everyone's doing bad, they'll say, oh, we're going to grade on a curve and make everyone look like they're doing better. But really, everyone's still doing not good. It's kind of silly. So that's what our whole point of this normal curve, and that's where we really see that. Another part where we want a normal curve is when we want something to be pretty exact. So tomorrow we're going to be talking a little bit, we're going to run some experiments tomorrow. We're going to do some testing on some products to see if those products overall on average are the same amount every time, or if it changes a lot. So this is where our mean is equal to our median, which is equal to our mode. So our mean is the calculated center, and our calculated center would still be in the center here. But this time that mean is together with the mode. So our mode is that highest point, which is right where that mean is. And our median, the middle, would also be right on there. And we had a couple of those. Remember when we did that back in Unit L? There was a couple where when we found the mean and the median, you guys were like, oh, it's the same number. That means that means it was a normal curve. Our data was centered.
I'm learning so much.
Are you? We just talked about what grading on a curve is, and it's blowing their minds.
Yeah. I've never been graded on a curve.
I have.
When
I was the curve, though, because I was the 100% stupid.
When I was, it was in calculus, and the person got like a 95 anyway, so it
Didn't matter.
affect me.
Yeah. So if we look at this one, if we look at the histogram, again, our histogram, is it exactly symmetrical? Does it exactly match on both sides?
Never been graded on the curve, and then recall an example of her being graded on the curve. Sorry, that was
Yep. Normally you get graded on a curve when like the best person gets like a B or C. So the best person in our class got an A, so it didn't really like make that much of a curve. What happened. All right, so as we look at this one, is this completely symmetrical? Does it match completely on both sides? Like this one matches this one? And that matches that one? No, it's not exactly matched, but when you look at that general curve, remember it's the overall idea. Overall idea is that it's having that hill in the middle. So this one, when we look at the tail, we have a tail on this side. That's a tail. But we also have a tail to begin with. So this one has two tails, one on each side. Remember the tail is where it kind of trails off, goes down low. All right, so far we've had a right skew or a positive skew, a normal curve or no skew. So what do we think is the last one using our powers of deduction, or induction, if you will, patterns? I have right, normal, what? A negative skew or a left skew. Yeah, we already did positive skew up there. That's where we got the positive, so negative. So it's right, left, and then this one's kind of our center, so left skew. Also known as a negative skew. I'm really bad at making W's is what I realized when I do this chapter. I need to work on my handwriting. W's. Alright, so as we take a look at our graph, again we have our X and our Y axis. Alright, this time it's going to start low, and then at the end it'll go up the hill, hits the top of the hill at the end, and then maybe starts coming down, but probably won't come all the way back down. So again, when we talk about left skew is when we look at the mean and where the mean is located compared to most of the data. This time the center of the data, the mean, this calculated center right here, is that to the left of most of the data or to the right? Yeah, to the left, because most of the data is over here, so the mean is to the left. So that's where we get that idea of left skew. All right, and then we have our median and our mode. I'm going to start with mode again. Mode is our most. So mode should happen at wherever the top of your hill is. Okay. If you want to label these, you can. So that's mode, mean. And then usually our median has to be somewhere kind of usually in the middle of that. We have way more information, way more data over here. So if I go high, low, high, low, high, low, eventually the middle will actually end up being somewhere kind of in the middle of up that hill. Okay, so mean is to the left, so that's where we get our left skew from. As we look at our data again here, it's not perfect. It goes up and down, up and down, up and down. That's generally what's going to happen in the real world. It's not all going to just go up, 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 up. But the overall idea is it starts low, and then it's going to gain, gain, gain. It goes up, and then we'll do a little hill over the top there. So when you look at it with actual data, sometimes that curve doesn't actually look 100% like we want it to. This would be like the ideal curve. But this is still a left skew curve when we look at it with actual data. And this one, what side is the tail on? The left. So this is a good way too, if you have a tough time, this is how most students end up remembering it, is based on the tail, because the tail is really easy to find. You don't have to do a lot of math thinking. You don't have to think about where is the center, where is the mean, where is the median. Rather than comparing all these parts, you could just compare where the tail is. The tail is on the left side, and this is a left skew. Our tail is on the right side. It's a right skew. So that's kind of a different way to look at it, is looking at what side the tail is on. Most people can identify a normal curve pretty quick. It's when the bump is in the middle. But for the left and right skew, it gets a little bit goofy. So that's one way to remember it. The tail is on the same side as the skew. So if the tail is on the left, it's a left skew. If the tail is on the right, it's a right skew. All right, so that was a lot of vocabulary today. Tomorrow we're going to be running some experiments, and we'll need to use this information as we run our experiments.
We're done, right?